Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello, everyone. Thank you for joining us for the 25th Oxygen Concentrator Talk call brought to you by the Oxygen Alliance. My name is Maui Lungu, and as usual, very pleased to be hosting the call. I am joined by my colleagues, Timothy Mtonga and Teto Sinjani, along with our usual technicians from OpenO2 and Sunrise. On the technicians panel, we have Kowinda Singh joining us from Chandigarh, India. We have Paulina Mohosho joining us from Johannesburg, South Africa. We also have Cynthia Chikomoni joining us from Mwanza, Malawi, and Georgie Kwanga, Daphne Magela, and Linda Mishoni joining us from Lilongwe, Malawi. So in case this is your first time, the Concentrator Talk is a virtual meeting that we host every Thursday from 2 to 3 p.m. Central African Time. And this is where we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So if you have any issues with the concentrator that you would like to be helped with, don't hesitate to reach out to us through our email address, info@oxygenalliance.org, and we'll do our best to respond to all those questions either during the call or on the next Concentrator Talk call. So in the call, we normally have polls at the end of some of the questions. So when they pop up, please respond to them. We'll also have a topic of interest, and today we'll be talking about concentrator maintenance standard operating procedure. All right, so now to jump on to our questions of the day. So our first question says, I am working on an ASAP New Life oxygen concentrator and I want to service the compressor, but I do not have spare cylinder sleeves to replace the worn out sleeves. Can I reuse the worn out cylinder sleeves? So I will ask Kowinda to respond to this one.
Thanks, Bobby. So in order to produce compressed air, there are several smaller components inside the compressor which work together. Among these components are the cylinder sleeves, which are the chambers where compression takes place. Piston cups are the components inside the compressor which sit on the top of the pistons. The function of these piston cups is to pull in the air from the intake and push it out to the exhaust by creating an airtight seal in the cylinder sleeves. The cylinder sleeves and piston cups are the mostly frequently replaced components whenever one is servicing the compressor. The different compressor models have cylinder sleeves which differ in height and diameter. Due to wear and tear, the internal lining of the sleeves become worn out and the amount of pressure that gets pushed out to the exhaust port is reduced. Hence, badly worn out sleeves must be replaced. So as you can see in the presentation also, hence badly worn out sleeves must be replaced. Therefore, in the case one has no spare cylinder sleeves to replace the ones which are worn out, they can reuse the worn out sleeves. This will depend upon the compressor model and also the extent of wear and tear. For the compressor models such as ZW140-E-2 and Thomas 2669, their sleeves have a height which is larger than the travel distance of the piston. This gives us the advantage to reuse the sleeves. Mostly for the sleeves of ZW140-A-2, only a quarter of the sleeve wears out, and on the other hand, about half of the sleeves in Thomas 2669 gets worn out, as we can see in the image also. The upper one is the good one and down one is the damaged one. So now to reuse these sleeves, gently clean the worn out portion of the sleeve with a piece of sandpaper You can dip the sandpaper in soapy water to make the cleaning easy, and make sure to wipe the sleeves with a cloth to make it dry. Then turn the sleeves upside down when putting it back in the compressor, so that the worn out portion is on the bottom side and the portion which is intact will be on the upper side. So this can help a lot in this. Thank you.
Thank you very much, Kuinda, for that explanation. I hope that helped to answer your question. And in case we have some comments or some follow-up questions that would like to make on this, we are free to do so. All right, it seems we do not have questions there. So we'll now move on to our second question. So the question says, an AirSep intensity 10 concentrator was brought to our maintenance workshop. I measured the oxygen purity with an oxygen analyzer, and it was fluctuating between 87.5 and 92%. After troubleshooting, it was discovered that the one-way valve placed near the outlet of the concentrator was damaged and it needed replacement. The hospital does not have any spare one-way valves available. There is a damaged Vilbis 525 concentrator in the workshop that we can scavenge spare parts from. Is there any problem if I take a one-way valve from the Vilbis 525 and place it in the AirSep concentrator? So I will ask George to respond to this one.
Thank you, Mary. One-way check valves in oxygen concentrators permit oxygen to flow in one direction only. This ensures that there is no backflow of oxygen from the patient into the oxygen concentrator. If the oxygen concentrator has a humidifier board attached to it, a one-way valve placed just before the flow emitter prevents backflow of water from the humidifier board into the oxygen concentrator. This prevents the damage of the zeolite inside the sieve beds. And another way, one-way check valves prevents fluctuations in the oxygen period of the oxygen concentrator. Check valve that are placed between the sieve beds and the accumulator tank ensures that the oxygen does not fall back in the paging sieve beds, which can reduce the purity. Since the oxygen is only allowed to flow out of oxygen out of the oxygen concentrator, a stable oxygen purity can be maintained. When one-way valve is not placed at the outlet, there's a back pressure that is created when the concentrator is switching off. The residual pressure and accumulated in the humidifier bottle gets pushed back inside the oxygen concentrator. If the water levels exceed the maximum in the humidifier bottle, some of the water gets pushed inside the concentrator, which can eventually end up in the sieve beds. There are different types of one-way valves. Usually these one-way check valves have specific operating pressure that they can operate at, and exceeding that pressure damages the valve. As you can see in the graphics, on the left, we have a low pressure check valve, and on the right, we have a high pressure check valve. An AirSep in test 10 has a recommended output pressure of 137 kPa, and the Vilbis 525 has recommended output pressure of 55 kPa. So as much as one-way valve from the Vilbis 525 can withstand the operating pressure of AirSep intensity, it may not be advised to swap around one-way valves, as the difference in the recommended output pressure would also mean that the one-way valves have different operating pressure also. The one-way check valve may not be able to withstand the pressure. So when replacing a one-way valve from another concentrator, ensure that the operating pressures are the same. Thank you so much.
Thank you very much, George, for that response. I hope that was clear for everyone. But in case we have some comments or questions that would like to ask, we are always free to do so. You can either come off mute or you can just paste it in the chat. So we have, yes, Mteto, I see you have a hand.
Yeah, so I actually just wanted to point out something, but maybe you can go ahead and launch the poll and then I'll make a comment.
Okay, I think that's on the side.
All right. So I just wanted to point out that when you introduce the high pressure on these check valves, you actually black it, and in order to know that it is not functioning, you introduce air both sides, and when it is passing through, when you introduce air both sides, just know that that check valve is actually damaged. So it's always important that when we want to put them in the concentrator. Sometimes they come like factory 4 damaged, so we need to test them before we actually introduce them in the concentrator. Yeah, that's it, Maui.
Great. So maybe just in case some of us don't know how to access the pause, if you're joining us using a computer, if you go to the bottom right of your screen, the icon on the far right is the activities button. So if you click on that, a window opens up where the pause menu is one of the options listed. If you are joining us using a mobile phone, then you click on the menus option, which should also be positioned on the bottom right. So if you click there, a window will open up where you have the activities button. So once you press on the activities button, you should be able to access the pause. Okay, so I think we can end the poll now. So it seems to be split 50-50. Some didn't know that the one-way valves have different operating pressures, and half of the votes knew that they have different operating pressures. All right, so moving on with our questions. So our next question says, during routine maintenance of a Longfian J5 oxygen concentrator, I noted that the copper pipe found on the cooler section was partially cut off just near one of the fins. Is there a simpler way to solve this problem than soldering with a copper rod? So I will ask Paulina to respond to this one.
Thank you, Mabi, for the question. When air has been compressed, its pressure and temperature rises. Thus, there is always a need for a cooling system in each and every concentrator to reduce the temperature of the compressed air. In some oxygen concentrator models, the cooling system is made up of a coiled hose, which is connected to the compressor exhaust, while in other concentrators, a pipe coming from the compressor exhaust runs above the compressor cooling fan in order to cool the air. The cooling system of a Longfian J5 oxygen concentrator consists of a fan and a copper pipe with aluminum fins on its surface. The fan helps in cooling the compressor, while the copper pipe helps in cooling the pressurized air coming from the compressor exhaust before it reaches the molecular sieve. As stated in the question above, one way of fixing a leakage on the copper pipe is to solder using a copper rod. In addition, an easy way to fix a leaking copper pipe in the cooler section of a J5 concentrator is to use any high performance adhesive, metal filler, and epoxy that can withstand high pressure and high temperature. Epoxy is formulated to set hard and bond well with most rigid metals. To fix the leak, make sure the area around the leak is free of loose dirt, rust, paint, oil, and grease. Wire brushing or sanding will help to enhance adhesion to smooth surfaces. Most epoxy comes with two tubes with different cap color codes. Follow the mixing procedure on the manual that comes with the adhesive metal fillers. When applied correctly, adhesive metal fillers are capable of withstanding operating temperature and pressure from the concentrator compressor. Thank you, Mabi.
Thank you very much, Paulina. I hope that explanation was clear for everyone, and hopefully it's going to help us with issues to do with that. But in case we have some questions or comments, we are always free to make those comments or ask those questions. All right, so no questions. So now we'll be moving on to our next question. So the question says, a newly employed biomedical engineer, I was assessing concentrators at the health center that has a COVID unit too. I found that only 5 concentrators that were being used in the wards and COVID unit. So the nurse in charge complained that the concentrators get hot after running for a short time. When I checked them out, I found out that the concentrators were being used while placed in a foam as shown in the image. When I asked why they placed the concentrator in the foam, I was told that they were preventing water and other dirt from getting to the concentrator. Upon removing the concentrator from the foam and opening it up, I saw that the base had started melting. What might have caused this, and how can I resolve this one? So I will ask Daphne to respond to this one.
Thanks, Mari. The foam shown on the photo seems to be the one used by manufacturers when packing concentrators in the boxes. If you look closely, you see that the foam has a sticker saying remove the foam when using the product. Concentrators need to have openings from which the compressor sucks ambient air from the surrounding, separates the oxygen from the nitrogen, and releases nitrogen back to the surrounding. For this process, the concentrator has openings used for the airflow. These are called exhaust screws that are found in the sides of the base. You can see those in the slide. These openings help in allowing air to enter the concentrator easily and also allow air to leave the concentrator, which also helps to control the heat inside the concentrator. If these openings are blocked, it is hard for the compressor to suck air from the surrounding, and this also causes the compressor to heat up and heat builds up inside the concentrator. It is also hard for nitrogen to escape from the concentrator since the outlets have been blocked. A rise in temperature in a concentrator can result in different things, like reducing purity and even melting the plastic of the concentrator, just as in your case. Removing the foam and operating the concentrator in an environment that is at least 1 meter away from the wall and other obstructing materials will enhance the performance of the concentrator. Thank you.
Thank you very much, Daphne, for that response. I hope that will help to solve that. If we have some questions or comments on this one, we are free to make those comments. Okay, seems we don't have any comments there. So now we'll proceed with our questions. So our next question says, I have a Devilbis 1025 oxygen concentrator that was brought to the workshop for fixing. It was suspected that water got to the seatbelts, and when the concentrator was running, the water got to the control board and caused a short circuit. I replaced the burnt board with a new one. I switched the concentrator on, and immediately the new board got bent again. I bought another one, and I'm afraid to lose it. What steps can I follow to save my oxygen concentrator? So I will ask Cynthia to answer this one. Cynthia, I think you forgot to unmute your mic. We can't hear you. Cynthia, we can't get you still. Okay, seems we've lost her there. So we'll skip that question for now. Hopefully she will be back then, and then we'll jump on to our next question. So our next question says, at our workshop, we have 3 oxygen concentrators that are in good shape, but the only problem is that they do not have power cables. Can I use a cable made for a laptop charger or a television screen on these concentrators? So I will ask Linda to respond to this one.
Thank you, Maui. It is not every power cord which you can use on oxygen concentrators. Wire gauge refers to the thickness of a wire, and it is what determines the purpose or the application of your cable. and each wire gauge is noted by a number. Small gauge numbers signify thicker wires, and while large gauge numbers represent thinner wires. American wire gauge (AWG) is a standard method for measuring the thickness or cross-section area of electrical conducting wire. Thickness of a cable affects its electrical properties, which are the resistance and current carrying capacity. This is so because resistance increases when with decreasing thickness, which in turn reduces the current. And also thin wires tend to heat up faster, hence they are not ideal for applications that require high current. Therefore, before you can put the cables on the concentrator, check they use the cable of the correct wire gauge. If you use a long and thin wire, the performance of the compressor will be affected due to increased resistance. That causes a decrease in the current as well as a voltage drop. This in turn will affect the oxygen purity of your concentrator. And there are two types of cables, a solid wire and a round stranded wire, as you can see in the graphics. Stranded wires are mostly used in concentrators because they are more flexible than the solid wires. And sometimes people tend to use the outer diameter of a cable insulation as they are like the thickness of the cable. So that is wrong. You have to, for the stranded wire cable, you have to calculate the cross-section area of every strand inside the cable and then multiply the cross-section area of a single strand by the total number of the strands inside that cable. And then you can use the number that you have as a result, and the number is in millimeters squared. So with this number, you can use it to refer to the chart and find its equivalent, the chart shown in the graphics, and find its equivalent gauge AWG value. For example, for 0.75 millimeters, if you get that number, you have to know that its equivalent AWG value is 18. So you have to use that kind of cable for your concentrator. Thank you, Maui.
Thank you very much, Linda, for that explanation. I hope that was clear for all of us, and I hope it helped to answer your questions. So we have another poll at the end of this question. So Mteto, if you'd please launch that poll.
Yeah, so I'm actually launching the poll now. So the poll says, did you know that the thickness of your power cord can affect the performance of an oxygen concentrator? So we'll just give it some time so that people can vote. And I'm interested to look at the feedback because we know that if you use like a very, very thin cable, you can literally smell the cable burning while the concentrator is running. So I think we need to be careful with that. So it seems like this is like something people have seen often because I've gotten like all yeses. So I'm going to end the poll now.
Okay, thank you very much, Mteto. Before we proceed, just a reminder to all of us that we always encourage you to share your email addresses with us in case you haven't done that already, so that we can add you to our mailing list. So this helps us to send you reminders of the concentrator talk, but then we'll also send you updates on the work that is happening in the Oxygen Alliance. So please share with us your email addresses in the chats, and please just let us know where you are joining from. Cynthia, are you back?
Yes, I am.
Okay, great. We had a question for you. So I'll just read it out. I think Ted already pasted it in the chat. So the question said, I have a DeVilbiss 1025 oxygen concentrator that was brought to the workshop for fixing. It was suspected that water got to the sieve beds, and when the concentrator was running, the water got to the control board and caused a short circuit. I replaced the bent board with a new one. I switched the concentrator on, and immediately the new board got bent. I brought another one, and I am afraid to lose it. What steps can I follow to save my oxygen concentrator?
Okay, so the first thing you need to do is dry and does not have any water inside that can cause any short circuit. So it could be possible that you still have water inside the device that got into the control board after you replaced it. The second thing is to check for the power coming from the socket. So there are times where the voltage goes up and exceeds the operating voltage of the device. For example, if your machine runs on 110 to 120 voltage AC, make sure that the power from your socket does not exceed that. And the same applies to the 1020 volts machines. If you're getting a high voltage, then try to get it fixed before connecting your concentrator. Another thing is that you need to take note on is the connection of the wires coming from the power switch going to the circuit board. For the 1025, if you are not careful enough, you can end up connecting the wires in the wrong positions, which can cause short circuits that can damage your control board. These wires have similar colors, so make sure that you pay attention to the colors when making the connections. So the graphic shows how the wires need to be connected. All the wires are connected in the correct positions on the switch. So try to work on the suggested solutions and carefully, and hopefully you can choose one of them to solve your issue. Thank you.
Thank you very much, Cynthia, for that response. I hope that was comprehensive to all of us and we understood it. But in case we have some questions, we are always welcome to ask those questions. All right, if we do not have any questions there, we will now take a slightly different direction. So we'll jump off the questions and now move on to our topic of interest for today. So today we'll be talking about the standard operating procedure. So George will be taking us through that. Over to you, George.
Thank you, Mwawi. As Maya has already said, we're going to talk about oxygen concentrator maintenance standard operating procedure. So just a background about the standard operating procedure, which in short just say SOP. It's a set of written guidelines outlining the steps that must be done to carry out a regular task. So to ensure that the organization maintains consistency and complies with the industry standards and even business standards, SOPs are supposed to be followed same way each time. So these SOPs are not only important to engineers, these SOPs are also very important to health facility administrators, clinical practitioners, planning staff, even policymakers. So all these people are supposed to be aware of how this is done. So I'll talk about the advantages of the oxygen maintenance standard operating procedure. So the SOPs helps in training unifying orientation. This is a documented set of instructions, make it possible to guarantee that all the new employees receive the same orientation, covering the steps of doing the work in the same amount of time. This will not only ensure that the new employees adapt fast, but it also ultimately save time and money. The written SOPs can also make daily operations more predictable and assist in making sure that each person is aware of the processes and even rules of their work. SOPs are particularly beneficial for creating employee review, even development plans, since they give specific document, for example, which expected from the employee. Another beneficial from having the SOP is that sometimes most workers can take a sick day, but with SOPs available, it is simpler to assign the task to another worker. This can also ensure that this new worker can accomplish the given task with a little guidance. Even straightforward procedures are not open to everyone. There are different interpretations. So when you have a written set of instruction, it is more helpful to standardize the way you do the work. Next slide. So in the graphics, you can see the concentrator maintenance SOP. This SOP was developed about years ago, just to help us when you're doing oxygen maintenance. So the SOP is not fixed. It is open to revision, and even with this SOP, there may be some of the things that will be done, that will be revised, and some of the steps that will be added to this original SOP. So going into detail into this SOP, the first thing you can see in this SOP when you're doing oxygen maintenance is that firstly, you're supposed to open the oxygen concentrator. This is basically removing the covers, and this will help you to have a view of the inside of the concentrator. So when you open your oxygen concentrator, the second thing that you need to do is to power it on. So you power the concentrator and observing what is happening. So if it is not powering on, you will need to check if the switch is on or not. So if it is not, if it is not on, you will need to replace the switch, or you need to fix the switch. But if it's okay, then you need to check your power cables and replace it if it is faulty. The other steps that you can see from that SOP is if the concentrator is powering on, you observe the sequence of the valve. So if the valve are not opening, you check the individual valve. For instance, in the case of solenoid valve, you can check individual valve. You can check the rotary valve or the four-way valve. If the individual valve or the rotary valve is okay, you then check the control board if it is okay. But if the valve are not good, you need to replace or you may fix them. The other step is that if the valves are okay and they're opening, you need to check now the oxygen concentration. So if the concentration is low, then you check the compressor pressure. But if the concentration is good, you know that your oxygen concentrator is okay. So in the case where the concentration is low, the second step that you're supposed to take is you need to check the compressor pressure. This is the pressure that is coming from the compressor that you need to check directly. So if the compressor pressure is not normal, then you check the relief valve on the compressor. So on the leaf valve, you check if it's being engaged. That would mean that you have high pressure. But if the leaf valve is not being engaged, it will indicate that you have issues with the compression kit. So you may consider changing. So if the measured compressor pressure is normal, the next step that you are supposed to do is to check the seatbelt pressure, whether it is low or high. So if you have high or low pressure in the seatbelt, it may indicate that you have some issues with the seatbelt. So for instance, the high pressure indicate that the seatbelts are contaminated. As such, you may consider replacing them or refill the zeolite. If the seatbelt pressure is normal, in the case above, you need to observe the patient output pressure. And on the oxygen concentrator, you have the pressure regulator, which if you observe that if you observe that the patient output pressure is not in the range where you're supposed to be, you adjust using this pressure regulator. But if the patient output pressure is normal, now what you need to do is to check for the leakages. This is starting from you start from the seatbelt, going up to the patient outlet. Thank you so much.
Thank you very much, George, for that presentation. I hope that was comprehensive enough and we all learned something from that. In case we have some questions or comments that would like to make, we are free to do so, and George will respond to all the follow-up questions that we might have. Right, it seems we do not have questions there. So we'll now jump back to our questions and proceed with the remaining ones. So the next question says, I was servicing a compressor on a Vubis 525 oxygen concentrator. After servicing it, I switched on the concentrator, but then the compressor was not spinning. What could be the cause and how can I solve this problem? So I'll ask Cynthia to respond to this one.
Thank you once again, Mari. So this usually happens when the valve plates have been switched when putting the compressor back together. If the valves are not placed into a proper position, the screw misses its notch and only moves until at a certain angle before it stops. It is always a good practice to mark the compressor before you disassemble it, so that during the replacement of the compressor kit, the exhaust side valves are not placed on the compressor head. In your case, you did not mark the contact between the head and the block before disassembling. So you have to test the compressor before connecting back together and putting back into the oxygen compressor or concentrator. After that, you need to hear if it's going to produce a normal sound and if the compressor will be spinning. So you have to also check if there will be no leakages and if the airflow is in the right direction. So you have to redo the assembling if any of these is not met. So in your case, just switch the valve plates again and try to run the compressor. It should spin. There is a video in our oxygen allowance website for reference, and the link will be pasted in the chat area. Thank you.
Thank you very much, Cynthia, for that explanation. Tato, if you haven't already, please paste that link in the chat so that people can reference from that. If you have some other follow-up questions on this explanation, we are free to ask those questions, or we can make some additional comments also if we have some. Right, it seems we do not have questions there. So we'll now move on to our next question. So our next question says, I am a biomedical technician of a certain district hospital. I have a concentrator which was producing a loud noise from the compressor. I was also getting low flow, low pressure, and low purity on the concentrator. I have tested the spare compressors of the same model from my oxygen concentrator graveyard, which I would like to replace the underperforming compressor with. Would you advise me on a test I would carry out to know which of these two compressors is in a better condition? So I'll ask Daphne to respond to this one.
Okay, thanks, Mari. So every compressor model has a performance chart provided by the manufacturer. The performance chart shows the performance of the compressor under different voltage ratings as provided by local electricity suppliers, for example, 230 volts or 115 volts. Two parameters are considered in terms of performance of a compressor: pressure and flow rate. A compressor will have specific flows it is supposed to reach at specific pressures when it is in good working condition. As time goes by, caps, sleeves, gaskets, and O-rings wear out. As they wear out, the compressor will not be able to reach the initial flows at the specified pressure values as given by the manufacturer. This is an indication that a compressor is underperforming and needs to be serviced by replacing caps, sleeves, gaskets, or O-rings. So on the slide, it shows a compressor service chart. This is a manufacturer's chart for a Thomas 2660. It shows the flow against pressure. For example, we can see that at 40 psi, it's supposed to give around 80 liters per minute. You then check the flow being produced by a compressor, pick the same pressure and check if it's giving out flow closer to what is given in the performance chart. If there is any difference, it means the performance has dropped. For you to accurately measure the flow at the specified pressure, you would need a way of controlling the output pressure of the compressor and measuring flow readings at those specific pressures. Flow readings can reach over 100 liters per minute. As such, this is not possible to be carried out with readily available tools or equipment. One approach you would use in your case is that of maximum pressure and maximum flow. As the compressor overhaul kits wear out, the compressor will not be able to achieve the maximum flow and maximum pressure reading as given by the manufacturer. So at maximum pressure, the compressor flow rate will be 0 liters per minute, and at maximum flow, the pressure will be 0 psi. The ZW280 compressor has a maximum flow of 94 liters per minute and a maximum pressure of 73 psi. As already said, it will be challenging to measure the maximum flow at 0 psi. As such, you should measure the maximum pressure of the two compressors. For you to measure the maximum pressure, you connect your pressure gauge to the exhaust of the compressor and block any other exhaust airways, including the pressure relief valve. Measure and record the maximum pressure of the two spare compressors that you have and compare with the maximum pressure given by the manufacturer. You will need to use the compressor which has a value closer to the maximum pressure given by the manufacturer, as this compressor is in a better condition. Thank you.
Thank you very much, Daphne, for that response. I hope that is clear and helps you, and hopefully that will help to solve your problems. In case we have some questions or comments on this question as well, we are always free to make those comments or ask those questions if we have them. Right, it seems we do not have any questions there. So we'll now move on to our final question of the session. So the question says, I am a biomedical engineer and I am currently working on an airset. The concentrator was giving low oxygen purity levels, so I refilled the sieve beds. After testing the concentrator, the purity was still low, so I then serviced the compressor. The purity is below 80% at 5 liters per minute, but falls within the normal ranges when I set it below 5 liters per minute. Can the oxygen concentrator still be recommended to be used? So I'll ask Linda to respond to this one.
Thank you, Maui. So first of all, it is not recommended to have an oxygen concentrator that produces low oxygen purity at the maximum rated flow rate, because some patients may be prescribed that maximum flow rate and they will not receive the right purities of oxygen. Since you have serviced both the compressor and the sieve beds, you might want to check for leaks in the piping. It could be that you are losing oxygen through leakages. The other things would be to check the patient's outlet pressure and make sure it is within the recommended ranges. If all of these are fine, then we'll leave one explanation. It could be your concentrator is designed to run on lithium-based zeolite and you refilled the sieve beds with sodium-based zeolite. What you need to do is refill your sieve beds with lithium-based zeolite. If you do not have lithium-based zeolite, but you still need to use the concentrator, I recommend that the oxygen concentrator should be labeled "do not use at above 4 liters per minute." It can be allocated to the pediatric ward where they administer flow rates below 4 liters per minute, since according to the World Health Organization, children below 5 years are prescribed low flow rates, mostly below 2 liters per minute, than adults who receive a therapy at above 4 liters per minute. Ensure that you make it known to all users, including the ward attendants and nurses, that they do not need to exceed the flow rate shown in the label. But sometimes, either due to negligence, communication barriers, or other factors, users tend to still try to use flow rates above 4 liters per minute. I would recommend that you use a needle valve at the outlet of a flow meter to control the flow. A needle valve is a valve that is used to accurately control flow rates of gases or fluids, although it is generally only capable of relatively low flow rates. It has a small port and a threaded needle-shaped plunger. During installation, you have to make sure that you put the needle valve pointing in the right direction. So the needle valve has an arrow pointing in to which direction the air will be flowing to. So you have to follow that and make sure that the valve and the knob on the flow meter are fully open. This allows free flow of air to the patient outlet. Once that is done, start turning the knob, the adjusting knob, as you can see in the graphics on the needle valve. You can turn it clockwise or anti-clockwise to either restrict the flow or increase the flow of air passing through the needle valve, respectively. You will notice that the ball in the flow meter will start dropping, and when it gets to your required flow, you have to use the locking knob, which is shown in the graphics, to lock the valve. Doing this will only allow air to flow at your desired flow rate, and the user will not be able to go above 4 liters per minute. Thank you. I hope this will help you to solve your problem.
Thank you very much, Linda, for that response. Indeed, I hope that will help them solve their problem. But in case some of us have questions or comments that we'd like to make on this question, we are free to make those comments. So we have a poll at the end of this question. So this is our final poll. So Tato, if you'd please launch that one up.
Thanks, Maui. Let me do that now. So I've launched the final poll. So it's asking that, have you used a needle valve to control the airflow rate before. So we just give it some time so that people can respond to this. So I myself have used a needle valve, more especially in, I think, in an aircept, because like 10-liter aircepts, they want you to put in lithium zeolite, and we only had like sodium-based zeolite, so we had to use the concentrator at 5 liters per minute, and it could only perform at 5 liters per minute. So this needle valve played a very, very good job during that time. So people are still voting. So it's actually in favor that people have used this needle valve before. It would be just interesting to just find out that, is it found locally wherever you are? You can type it in the chat if that is possible. So yeah, so Maui, I've ended the poll. So I have more yeses.
Okay, great. I don't see any responses in the chat yet. Yeah, but it's interesting to know that people have also used this technique. All right, so reaching this far, this now brings us to the end of our call today. And I would like to thank you all for joining us for the call today. It's wonderful to have you all the time. Hopefully the solutions that we give on the call don't just help those who ask the questions, but help everyone else. So in case you missed some of our previous talks, we have a YouTube channel. So we record each call and we post the recordings on our YouTube channel. So if you go on YouTube and search for Oxygen Alliance, you will be able to access all the videos from the previous calls. We also have a website, so the website also has more resources. So if you go on the website, oxygenalliance.org, you should be able to get a lot of information from there as well. Teto, I see you have a hand up.
Yeah, before maybe you also close, I just wanted to maybe add on the video we have added recently. I wanted to say about it that we have added a video on YouTube, which is doing a breakdown of an OLE5 oxygen concentrator. So for those who have come across that oxygen concentrator, I think this might help you to actually fix some of the problems or identify different components on that oxygen concentrator. So I'm going to paste the link in the chat now. Thanks, Maui.
Thank you very much, Mteto. But before we jump off, so next week we will not be having our normal question Q&A, but then we will have our monthly oxygen talk. So the oxygen talk is where we pick a topic that is not just focused on oxygen concentrators, but then focused on oxygen, medical oxygen in general. So this coming week, we'll be having that session. So please don't miss out. We'll be having a guest speaker from Devilbis, and they have prepared a lot for us. So let's make sure that we join the call and learn a lot from Devilbis. So Devilbis is one of the successful oxygen concentrator manufacturers. So we'll have a chance to learn from them. Please bring in a lot of questions also, so that we ask as much as we can, and then they can help out with our problems. So reaching this far, thank you all for coming, and I wish you a great week and a great weekend ahead, and we'll see you again in our oxygen talk next week. Goodbye.